Question number 1. What is the dimension for pressure? So when you want to find dimension of pressure, first maybe you can write the equation of pressure. Pressure equals force over area. So you want to find dimension for pressure. So put pressure in bracket, F in bracket, and area in bracket. Okay, so force is mass times acceleration, and area is length times length. Alright, and then dimension for mass is m, and dimension for A is acceleration is L per t squared, and dimension for length is L. So this is L times L, so this one will be L squared. So simplify this one. So you're gonna have ml negative 1 per t squared. So the answer is D. Okay, the answer is D. Number 1 is D. Okay, and then we can proceed to number 2. A speeding van is traveling at constant speed of 10 meters per second on straight road. It passes a stationary car that immediately accelerates from rest with an acceleration 2.5 meters per second squared. Calculate the time taken for the car to overtake the van. Okay, so car overtake the van, that's mean total displacement of the car is equals total displacement of the van. Okay, at the same time. Okay, at the same time. Alright, so for van, okay, for van it move with constant speed. Okay, it move with constant speed. So for constant speed, the equation is V equals S over T. So displacement for the van is V times T, where V of the van is equals U of the van because it is moving with constant speed. So this value equals 10. So displacement of the van equals 10 t. Okay, how about the car? Okay, the car accelerate from rest. That means initial velocity u is 0, acceleration 2.5 meter per second squared. So this car have acceleration, so you cannot use equation V equals S over T. So you have to use either one of 4 equation of uniformly accelerated motion equation. Okay, so perhaps you can use this. S equals ut plus half at squared. Okay, so S car, okay, displacement of the car equals initial velocity of the car, which is 0, plus half acceleration of the car is 2.5 times t squared. Alright, and then S1 equals S car. S1 equals S car. Then you can equating this equation. Then t equals half 2.5 t squared, and then simplify. Okay, simplify. Then t equals 1.25 t squared. Okay, so rearrange this equation. 1.25 t squared minus 10 t equals 0, and then you can factorize 1.25 minus 10 equals 0. So t equals 10 over 1.25. So it is equals 8 seconds. So the answer for number 2 is D. Okay, 8 seconds. Alright. And then number 3. Zaki throws a ball straight upward and reach maximum height in 3 seconds. Okay, so this is the ground level, and then this is the ball. Okay, ball. Okay, the ball might be from the ground level or from any position or any level from the ground. Okay, and it reached maximum height here. This is the maximum height. Okay, so concept for maximum height. At maximum height, V is 0. V at component Y is 0. Okay, because this is free fall. The only component in this motion is the Y component. So you just can write V equals 0. Okay, V equals 0. So you can use equation for free fall. V equals U minus GT. So V is 0. U is the unknown that you have to find. Okay, initial velocity of the ball. G is 9.81, and time taken for the ball reach the maximum height is 3. So U equals 29.43 meter per second. So the answer for number 3 is C. Okay, then number 4. Okay, number 4. A ball is thrown horizontally. Okay, ball is thrown horizontally from the roof. Okay, from the roof of the building as shown in figure 1. The initial speed of the ball is 12 meters per second. Okay, so the ball move at horizontal. So that means this is the U, and this one is also the UX. Okay, UX. It hit the ground at an angle 60 degrees with the horizontal. Calculate the magnitude of the velocity of the ball after 5 seconds. Okay. Okay, after 5 seconds. Okay. So actually you don't have to use this information here. Okay, so this is the method of final velocity V. This is the X component, and this one is the Y component. Okay, so the question asks you to calculate the method of the velocity of the ball after 5 seconds. Okay, after 5 seconds. So velocity at 5 seconds will have V at component X and V at component Y. Okay, where V at component X is equals to U at component X, because for X component velocity is constant. It's always the same. So it is 12. Alright. How about V for component Y? Okay, so V for component Y, you can use equation Vy equals Uy minus GT. Okay, where Uy is 0. Okay, because initially the ball moved at horizontal, so there is no component Y for initial speed, and then G is 9.81, and then T is 5 seconds. So Vy equals negative 49.05. Okay, maybe V at 5 seconds, or position of the ball at 5 seconds, maybe somewhere here. Okay, maybe somewhere here. this is the Vx, this is the Vy, and then this is the V. Okay, so you can determine the magnitude, okay, of the V by using V equals square root Vx squared plus Vy squared. Okay, so Vx is 12 and Vy is negative 49.05 squared. Okay, square root answer. So you're gonna have V equals 50.50 meter per second. So the answer is D. Okay, the answer is D. Number 4D. Alright. And then number 5. Okay. And then number 5. This one is the number 5. 1,300 kilogram lorry moving with velocity 8 meter per second collides with 1,500 kilogram lorry which is at rest. So we have two lorries. Okay, lorry A collide with lorry B. Okay, or maybe you can say lorry 1 collides with lorry 2. Okay, their masses are different. Okay, and then after the collision they move together, okay, with same final velocity. So A and B, okay, stick together and move with same final velocity. So this is initial and this one is the final. Okay, so you can use principle of conservation of momentum. Total momentum initial equals total momentum final. So this one will be MA/UA plus MV/UB. So the final momentum will be MA plus MB times V. So they share same final velocity. Substitute mass of lorry A, which is 1,300, and the initial speed of the lorry A, which is 8, and lorry B at rest. Okay, so UB is 0. And then MA plus MB times V, which is the unknown that you have to find. So V equals 3.71 meter per second. So the answer is D. Okay, this one is number 5. Okay, number 5 is D. And then proceed to number 6. Number 6. A golf ball with mass 0.1 kilogram experience a force of 1000 Newton while in contact with a golf club. It moves away from the golf club with velocity 20 meters per second. Calculate the time during which the golf club was in contact with the ball. Okay, it's like this. This is the golf club and this is the golf ball. Alright, so the ball move away. Okay, move away from the golf club, maybe after hitting by the golf club. Okay, with velocity 20 meter per second. Alright, so you can use concept of impulse. FT, impulse equals change of momentum. Okay, mv minus mu. So substitute force 1000, and t is the unknown that you have to find, and then substitute mass of the ball. It is 0.1. Okay, this one you can factorize. The final velocity is 20, and the initial velocity of the ball is 0. So the time in contact is 2 times 10 to the power of negative 3 seconds. Okay, 2 times 10 to the power of negative 3 seconds. So the answer is B. Okay, the answer is B. Okay, how about you draw ball like this, and the golf club here. So the ball move away from the golf club. You might have t negative. Okay, but then you have to choose answer positive for time taken, because for time is a scalar quantity. It has no direction and it has no negative sign. So just choose time positive. Okay, number 7. Two blocks of masses m1 and m2 are placed on a horizontal frictionless surface as shown in figure. A force of 50 Newton pulls the system, and its acceleration is 3.1 meter per second squared. Calculate the value of t if m1 10 kg and m2 6 kg. Okay, so we can consider for m1. Okay, so forces acting on m1 is the normal force and weight, and then tension away from m1, and pull force, okay, 50 Newton to the left. Okay, so m1 accelerate to the left. Okay, m1 accelerate to the left. Okay, I'm gonna highlight the component of the acceleration, okay, or the direction of the motion. Okay, so you can apply net force x equals ma. So force, which is the same direction of acceleration, is 50 Newton. So 50 Newton is positive, and t is in opposite direction of the motion, so t is negative. So actually this one is 50 plus negative t, okay, equals ma. So m is mass of the m1, okay, 10 kg, and acceleration is 3.1. So t equals 19 Newton. So the answer is D. Okay, then number 8. A man of mass 85 kg is standing in a lift. Okay, so this is the man in a lift. Okay, in a lift, accelerating downward. Okay, so it has acceleration downward. Okay, acceleration downward. Calculate the reaction force exerted on the man. Okay, calculate the reaction force. Reaction force means the N. Okay, so forces acting on this man is the weight vertically downward and the normal force, okay, perpendicular to the surface. So the concept is net force Y equals ma. So weight is in the same direction of acceleration, so weight is positive, and normal force is in opposite direction of acceleration, so normal force is negative, equals ma. So let n be the subject, n equals mg minus ma. Okay, so you can factorize, okay, mg minus a, and then substitute mass 85 kilogram, g is 9.81, and acceleration is 0.45. so you're gonna have normal force or the reaction force is 795.6 Newton. Okay, so the answer is C. Okay, number 9 is C. And then proceed to number 10. Okay, proceed to number 10. Okay, a box of mass 10 kg is pulled by a 25 Newton of force which is 30-degree inclined from a horizontal surface as shown. If the box travels 4 meters, so this is the S, along the surface, determine the work done by applied force. Okay, so work done by the applied force is equals to applied force dot S. So whenever you want to use this formula, make sure F is the component which is parallel to the displacement. So F which is parallel to the component is this one, okay, Fx. Okay, so it is the F cos theta times S. Then you can substitute F. Okay, you can substitute F, or you can substitute F. F is 25 and theta is 30 degree and the displacement is 4. So work done by the applied force equals 86.6 joule. Okay, 86.6 joule. Okay, so the answer is C. Okay, the answer is C for number 9. And then number 10, a force of magnitude 600 Newton cause an extension of 18 cm. Okay, so from this one you can determine K. Okay, from F equals Kx. Substitute F 600 Newton and K is unknown, and then X is 18 cm. You must convert to meter. Okay, so K equals 3.33 times 10 to the power of 3. Okay, this is the spring constant. Okay, this is the spring constant. And then you have to calculate the elastic potential energy of the spring when the extension is 40 cm. So formula for elastic potential energy is Us equals half kx squared. Substitute k 3.33 times 10 to the power of 3 and x is 40 cm. So you have to convert to meter and then you have to square this one. Don't forget to square. So you can have the answer is 266.67 joule. Okay, so the answer is A. So number 10 is A. Alright. And then number 11. Okay, number 11. A motor is lifting an object with mass 35 kg at constant speed 6 meters per second. Calculate the power developed by the motor. Okay, so the motor moves with constant speed. So power is given by F dot V. Okay, power equals F dot V. But then you have to calculate or identify the value of F. Okay, so the value of F is from this one. Okay, from this concept. Okay, so this is the object. So forces acting on the object is the W, and then the lifting force. Okay, So because the motor moving with constant speed, so the concept is net force Y equals 0. So F minus W equals 0. So F equals W. Okay. So W is mg. W equals mg. So substitute mass 35, G is 9.81. So you're gonna have F equals 343.35. Okay, 343.35 Newton. Then you can substitute here. Okay, 343.35 times V is 6. So the power equals 2.06 times 10 to the power of 3. 2.06 times 10 to the power of 3 watt. So number 11 is, the answer for number 11 is A. Alright, and then number 12. Okay, number 12. A man of mass 90 kg swings from a rope that is 3 meters long. Okay, his speed at the bottom of the swing is 4 meters per second. What is the net force acting on him? Okay, it is like this. This is the man. Okay, and then swing from a rope. Okay, this is the rope. Okay, rope. So the man swing. Okay, so the man makes circular motion. Okay, circular motion. Okay, so force acting on the man is the weight vertically downward at the bottom, and then tension away from the man. So net force acting on the man actually is the centripetal force. Okay, so you can use concept FC equals MAC. Alright, FC equals MAC. Okay, so AC you can substitute with V squared over R. So you're gonna have mv squared over R. Okay, then substitute mass of the man 90 kg and the speed is 4. Okay, and the radius of the circular motion is equals or the same as the length of the rope, okay, which is 3. So the answer is 480 Newton. Okay, so number 12 is A. And then number 13, the gravitational force of attraction between two masses is 30 Newton. Okay, the mass of one object is double and distance between them is half. What is the new force attraction between the two masses? Okay, so gravitational force is given by Fg equals G mass object 1 times mass object 2 over distance squared. Okay, over distance squared. So the gravitational force is 30. Okay, where m1 is unknown, m2 unknown, and distance between them is also unknown. Okay, and then the gravitational force, the new gravitational force Fg is equals G, the new mass, okay, the new mass, and over the new distance, okay, where the new mass of M1 is double of the original mass of M1, and the new distance between them is half of the original distance. Okay, so you have to substitute here. Okay, M1 is 2 M1 and M2 is still the same. Alright, so this one become half R squared. Don't forget to square all of them. Okay, you have to square half R. Okay, for the whole half R. Okay, and then bring G M1 M2 here. So simplify 2 over half squared. Okay, that's mean this one. Okay, let me circle this. 2 over 1 over 4. 2 over 1 over 4 equals 8. So for this one we get 8 G M1 M2 over R squared, where G M1 M2 over R squared is 30. Okay, value of G M1 M2 over R squared is equals 30. So Fg prime equals 8 times 30. Okay, 8 times 30. So equals 240 Newton. So the answer is D. Okay, the answer is D for number 13. Okay, number 13. And then number 14. Okay, this is number 14. At the surface of the Earth, satellite has weight W. Okay, at Earth's surface. The satellite is projected into a circular orbit whose radius is equal to twice the radius of the Earth. What happened to the new weight of the satellite? Alright, so at Earth's surface, or on Earth's surface, okay, R is equals radius of Earth. Okay, this is the Earth, and then this one is the satellite. Satellite on Earth's surface. Okay, so for this one, okay, from Fg equals mass times acceleration due to gravity. Okay, where Fg is G, mass satellite, mass Earth, over R squared, where R is the radius of Earth. So M here is mass of the satellite times Ag. So you can cancel mass of the satellite. Alright, so Ag equals G mass Earth over radius of Earth squared. This is acceleration due to gravity on Earth's surface. So weight on Earth's surface, W, equals mass times acceleration due to gravity, Ag, or you can also write G. Okay, so weight equals mass, G mass of Earth over radius of Earth squared. Okay, this one is on Earth's surface. And then when the satellite at circular orbit, okay, higher position, like this. Maybe can use this color to differentiate. Okay, this one satellite on satellite on circular orbit. So the new position R is twice radius of Earth. Okay, whose radius is equal to twice radius of Earth. Okay, it is like this. This is the Earth, and then this one is the satellite. Okay, so the new R is twice of radius of Earth. Okay, so this is the new R. The new R. Okay, maybe we can write R prime. Okay, R prime. So for this one, KFG is equals MAG as well. So G mass satellite times mass Earth over the new R squared, equals mass of the satellite times AG new. AG new. So you can cancel mass of the satellite. And then substitute R in terms of radius of Earth. It is twice a radius of Earth squared, so equals AG prime. So this one become GME over RE squared. 1 over 4. 1 over 4 GME over RE squared. This is the new assertion due to gravity on new position. On new position. So we can say that the new AG is equals 1 over 4 AG on Earth surface. So weight, weight of the satellite, the new weight equals to mass times assertion due to gravity new. So it is equals to 1 over 4 AG. So it is 1 over 4 MAG. Where mass times AG is W. This one is equals to W. So the new weight equals 1 over 4 W. So the answer for number 14 is D, 1 over 4 W. And then number 15, number 15, a particle of mass 0.2 kilogram move with simple harmonic motion of amplitude 2 times 10 to the power of negative 2 meter. This is amplitude. And this one is the mass. If the total energy E of the particle is 4 times 10 to the power of negative 5 joule. Determine the period of the motion. So total energy here is the total energy of simple harmonic motion. Okay, the formula is given by E equals half m omega squared a squared. So substitute E 4 times 10 to the power of negative 5. Okay, and then mass 0.2, omega is unknown, and the amplitude is 2 times 10 to the power of negative 2 squared. So you can determine omega. Omega equals 1. And then from formula omega equals 2 pi over period. Okay, substitute omega equals 1. Okay, so you can calculate period. So period equals 2 pi second. Okay, period equals 2 pi second. So number 15 answer is D. Okay, and then for number 16. Okay, number 16. A body move with simple harmonic motion of amplitude A and frequency y over 2 pi. Okay, amplitude A and frequency y over 2 pi. Amplitude is A and frequency is y over 2 pi. Okay. Calculate the magnitude of the acceleration when the body is at maximum displacement. Okay, so formula for acceleration of simple harmonic motion is given by A equals omega squared x or negative omega squared x. So at x at maximum displacement, okay, so A equals omega squared times amplitude. Okay, omega squared times amplitude. Alright, so substitute omega. Okay, formula of omega is 2 pi f. Okay, 2 pi f squared then times amplitude. Okay, so 2 pi f is y over 2 pi squared times A. So you can cancel 2 pi. So acceleration equals y squared A. Okay, y squared A or A y squared. A y squared. So the answer is C. Okay, the answer is C. Number 17. And then, sorry, number 16. And then number 17. Okay, this is number 17. A mass M hangs in equilibrium, okay, from end of a vertical spring. Okay, so it is like this. This is the spring and this is mass M. Okay, the oscillation of the mass M is started by being stretched 10 cm from equilibrium position. Okay, so when it stretched 10 cm from equilibrium position, okay, when you release the object or the mass M, so the object will oscillate, okay, from negative A to equilibrium position and then to the positive A. Okay, so this is simple harmonic motion. Okay, so from this information, the amplitude, okay, the amplitude of the SHM is 10 cm. Okay, and then from equilibrium and then release. The time for M to travel back to the equilibrium position, that means time taken from this point, from this point to equilibrium position, T is 0.5 second. So we can determine the period. Period is time taken. Time taken to make one complete oscillation. It is from here, from negative A to the x equals 0, and then to the positive A. And then from positive A to equilibrium position, and then back to negative A. So this is one complete cycle. So period of this SHM is T, time taken, T times 4. Because we have 4 segments here. 1, 2, 3, 4. So 0.5 times 4. So equals 2 seconds. 2 seconds. So amplitude 10 cm and period 2 seconds. Amplitude and period. Amplitude 10 cm and period 2 seconds. So the answer for number 17 is B. 10 cm 2 seconds. And then proceed to number 18. Number 18. An object attached to a spring execute SHM. With an amplitude 6 cm. This is A. Number of cycle for every 2 seconds is 10 cycle. So what is this? Number of cycle for every 2 seconds is 10 cycle. So from this statement, we can determine frequency. Frequency is number of cycle that can be made in 1 second. So frequency equals 10 cycle over 2 seconds. So frequency equals 5 Hz. So from this question, amplitude is 6 cm and frequency 5 Hz. And then from this information, when it is at 4 cm from equilibrium position, the force acting on the object is 12 Newton. So from this one, we can determine K. From F equals Kx. So F is 12, K is unknown, X is 4 cm. You have to convert to M. So K equals 300 Newton per meter. Newton per meter. So we can use formula period for simple harmonic motion for vertical spring oscillation, which is T equals 2 pi sert M over K. So because m is the unknown that you have to find, so let us eliminate the third. So this one become t squared equals 4 pi squared m over k. Okay, so substitute t period. So period is 1 over f. Okay, where f is 5. Okay, so 1 over 5 squared, 4 pi squared. M is the unknown that you have to find, and k is 300. So you can determine mass. So mass is 0.304 kilogram. Okay, so the answer is B for number 18. Okay, and then number 19. Okay, number 19. Two progressive waves in a long string are represented by equation y1 equals 0.02 sin 30x minus 400t and y2 0.02 sin 30x plus 400t. That means wave 1 propagate to the right and wave 2 propagate to the left. Okay. Alright, so both waves travel in opposite direction and form a stationary wave. Okay, so interference happen. Okay, which of the following expression best describe the stationary wave? Okay, so you can get the value or get the equation for the stationary wave. Okay, y equals y1 plus y2. So the amplitude will be double. 0.02 times 2 equals 0.04, and then this one become cos kx. So cos 30x sin omega t sin 400t. So the answer is B. Okay, 0.04 cos 30x sin 400t.